Hello friends, myself R.D. Mahajan presenting my one more video on Newton's backward interpolation formula. For that, uh, see the backward difference table. We have equispace values for x as x0, x1, x2, x3 up to xn, and the corresponding values of y are y0, y1, y2, y3 and up to yn. Then first backward difference, inverted operator del operated on y as backward difference of y1 as y1 minus y0, backward difference of y2 as y2 minus y1, y3 minus y2 as backward difference of y3, and so on. The last is a backward difference of yn. Then differences of these differences as second order backward differences, del square inverted del square y2 as del y2 minus del y1, then del y3 minus del y2 as del square y3. It is inverted del operator used for backward differences, and so on. The last one is del square yn, inverted del square yn. This forms the second order differences. If we take the differences of this second order differences, we get third order differences as del cube y, as first one is del square y3 minus del square y2 is del cube y3, and so on. Last is del cube yn. And if we continue this, lastly we have nth order backward difference as nth order backward difference of yn. We underline the last row xn corresponding yn, first backward difference, second backward difference, third backward difference, third order backward difference, and so on, nth order backward difference. Here the values are equispace. Let's consider x is equal to xn plus ph. Therefore, it implies we have p as x minus xn by h. That is the value for p. Therefore, p we get as x minus xn divided by h. And then Newton's backward interpolation formula is given by, once again here also I am taking this as a standard result. I am not taking any derivation part. Therefore, y of x is equal to, it is yn first term, p into delta yn plus p into p plus 1 by 2 factorial del square yn plus p plus 1 p plus 2 divided by 3 factorial del cube yn. Here del is the inverse operator of that del used for backward difference, or it is also called as NEPLA. Therefore, it is NEPLA yn, NEPLA square yn, NEPLA cube yn, and so on. The last one is p plus 1, p plus 2, so on. Last term is p plus n minus 1 divided by n factorial, nth order backward difference of yn. Therefore, whatever this formula, it is called as Newton's backward interpolation formula, and it is used to find a value of f of x, a value of y for x which lies near the end of the table. If that value lies in the bottom of that table, then we can use Newton's backward interpolation formula. Let us see one simple example for that Newton's interpolation formula, backward interpolation formula. Example, find y at 4.2 using Newton's backward interpolation formula for the given data. That given data is values of x and y are, values of x are 1, 2, 3, 4, 5, equispace. The distance between two success values is 1. h is 1 here, and the corresponding values of y are -1, 2, 7, 14 and 23. And we require to find the value of y at 4.2. 4.2 is in between 4 and 5, which is at the end of the table, and that's why we have to apply Newton's backward interpolation formula. And therefore, first step is we have to prepare a backward difference table. Therefore, finding the differences of these values of y, 2 minus -1, we get 3. We write in between these two values as backward difference of y1. y1 is here 2. Then 7 minus 2, we get that backward difference as 5. 14 minus 7, we get 7. 23 minus 14, we have 9. Then differences of this first backward differences: 5 minus 3, we get 2. 7 minus 5, we get 2. And 9 minus 7, again 2. Therefore, these are the second order backward differences. Then differences of these differences to obtain the third order differences: 2 minus 2, we get 0. And 2 minus 2, we get 0. And then differences of these differences, we get fourth order difference, backward difference, as 0 minus 0, we get 0. As we have to obtain a way to find the value of y at 4.2 using Newton's backward interpolation formula, we underline this xn. Here it is x0, x1, x2, x3, x4. x4 corresponding y4. Then del of y4, del square of y4, del cube of y4, and del raised to 4 y4. A last row. Then applying that, first we find the value of p as x minus xn by h, as I had discussed in the earlier part, where the value of x is 4.2, xn last value, that is 5, and h is 1. Therefore, 4.2 minus 5, we get that value as minus 0.8 is the value for p. And then applying using Newton's backward interpolation formula. That formula is y of x is equal to yn plus p into del yn. Then it is p plus 1 by 2 factorial del square yn. Next one is p plus 1, p plus 2 divided by 3 factorial, and del cube yn. Last one p plus 1, p plus 2, p plus 3 divided by 4 factorial, and del raised to 4 yn, as we are up to fourth order differences. This is the last term. And then substituting the values, we get y at 4.2 as yn. The value of yn is 23. The value of p is minus 0.8 into del yn. The value of del yn is 9 from the table, plus p minus 0.8 into p plus 1 minus 0.8 plus 1 divided by 2 factorial. Del square, the value of del square is 2, and next del cube and del raised to 4, as these two values are 0, that term becomes 0. And then simplifying it, we get that value as 23, 9 into 0.8 minus 7.2, 2 to get cancelled, we have 1 minus 0.8, we get 0.2, and into minus 0.8, and therefore we get that value as 23 minus 7.2 and minus 8 to the 16, 1.6, oh sorry, 0.16. Therefore, it is 23 minus 7.2 and minus 0.16. If you take the addition of all this, we get that value as 15.64 as the required answer by Newton's backward interpolation formula. And we cross check it. The value for 4 it is 14, value of y is 14, and for 5 it is 23. And that value of 4.2 is in between this 4 and 5. Therefore, y also must be in between 14 and 23. Therefore, it is greater than 14 and less than 23. Therefore, whatever the value we have is the correct one. Therefore, y at 4.2 is 15.64. Therefore, in this way, I have explained one example for Newton's forward interpolation and Newton's backward interpolation formula. One more I will discuss in my next video. If you like my video, please share it as well as subscribe to my channel to get notification for my new videos. Thank you.